So, as we already studied about the application of moment of force, now what is moment of force in mathematical terms is, so actually the turning effect of a force is called the moment of a force. Okay, so as we have to check the example, okay, for learning it more further and easily, so let me draw a example here. So here we have a white space. Okay, so now let us take an example of a rod. So let's take this point as the hinge point where it is fixed, and we are applying the force here. So what will happen? This rod will move like this. This rod will move, or you can say rotate about the hinge point. Okay, so what will happen? You just applied the force here, and the force is turning the effect. Force is creating the effect of turning of the object. So this is called the turning effect of force, and this is also known as moment of force. So let us take a very beautiful example that if we apply the force at the end point of this part, so what will happen? It will apply the same turning effect. It will apply the same turning effect on this by the force. Okay, now what will happen if we change the places of this point where we are applying the force? So if we change the place of this part or this point to this point and we will apply the force here, the turning effect gets low. Why it will get slow? Because the distance between the hinge point and the turning effect gets low. So what you will understand by this method that is that by applying this method we can see the example here or the formula here, that the moment of force is depends upon the amount of force you are applying and the perpendicular distance of the line of action of the force from fulcrum. Fulcrum is the hinge point. So let us take this example here. So here this is the hinge point which is fixed. Okay, so this point is already fixed. So if this point is fixed, that means this point is not moving. This point is always stationary. Okay, so if we apply the force of 5 Newton here, what will happen? This gate will turn like this, and the distance is maximum here. The distance is maximum here. The distance between these hinge point and the application of force is maximum. So the turning effect is maximum here. What will happen if you change the point where you are applying the force here? So if we apply the force here at the midpoint of the gate, the turning effects gets low. Why it will get slow? Because the distance is small. As the hinge and the point of application of force, the distance is become small. So by this method you can simply derive the formula that the moment of force depends upon the amount of force it is applied and the distance between the hinge point and the fulcrum, the distance between the fulcrum and the point of application of force. So this is written is here. So this is written here. Okay, moment of force is equals to force into perpendicular distance of the line of action of the force from the fulcrum. So what will happen? How we'll find the moment of force of these two examples? So let me find the moment of force here. So for finding the moment of force, you just need to write m here, and the force, you have to use the force, like the force is 5 Newton, and the distance between the hinge point and the point of application, which is 3. So multiply it by 3. So our moment of force is 15 Newton meter. 15 Newton meter. And always remember the force is applying perpendicularly to the surface of the gate. Okay, so now in how we'll find the moment of force of this point? So moment of force of this point will be m is equals to 5 of this force, and the distance is 1.5. So as you, if you multiply this, if you will multiply this value and compare it with this value, this is the greater moment of force and this is the very lesser moment of force. So I hope you will understand.